टेक्नोलॉजी ना जब भी आती है तो लोग ही फट जाती है।
कि भारत के युवा पढ़ाई के साथ ही स्किल में भी उतने ही दक्ष हों।
Welcome back friends to Skill Raptor. I am your host Atharva. Today we are going to see a very interesting problem, that is how to design a pumping system for a real life building. So let me show you a small video first. So this is a pumping system of a building. You can see a sump tank here from where water which is stored is being pumped to the top side of the building. These are the pipelines which connect, and this is how the water is being pumped at top of the building. This is the building around 7 storied. We can assume around 30 meters of height. So as you have seen in the video that we are trying to design a simple plumbing system to pump water to the top floor of the building. You can see in the figure. So this is a small replica model which we have made. So according to that, we will be designing a pump system. Here you can see a pump, a well, then there is a valve here and the pipeline system, and top side is the tank. And the lengths of the pipe are mentioned. These are taken roughly from the video which we saw. So what we are trying to achieve here? So we want to fill a tank with a size of 60,000 liters. Then time to fill the tank is 2 hours. Pipe size and make is given. So 2-inch schedule 40 carbon steel. Valve will be assuming for gate valve here. Make PVC make, and we'll be finding power requirements for the pump and pressure drop. So these are what we are going to see. So let's move on to the our interface of DWSIM and start making. So here I am on the interface of DWSIM. You can see on the top left corner there is a file button. Just press on it and click the first option, that is new process simulation model. I am clicking that. So after you click, there will be a window. So a new project is being opened here, and it will ask you for configuration of a basic configuration. We'll see that how to do that. You can see simulation configuration wizard. First is introduction. Just press next. Here we have to select the compounds. So water is actually our only compound here, so makes our work little easy. So I have typed water. Check on this. Press next. Here are the property packages. So basically what kind of a thermodynamic property we want to solve our problem. Since our problem involves only water, so you can select steam table. Just double click on that. It gets selected on the right hand panel here in blue, you can see, and just press next. System units, take C5 because it's a simple to operate with. So C5 is the system unit, and then press finish. Now I need to first choose the basic equipments which will be required to simulate this problem. On bottom side you can see pressure changers, then separators and tanks. So firstly just select a stream which is a material inlet stream. It is a inlet. Just I have dragged it there. Then after inlet we need to have pressure changers. So under the tab you can see different pressure changing equipments. So we need a piping segment and a pump. So I am just dragging and dropping. So this is the pipe from inlet. So this is the inlet and this is the pipe which will go into the pump. So I have to select a pump. Okay, so I have selected a pump, dragged it, and then I have a second piping segment. Now I will also explain you what I mean by second piping segment. This is my second piping segment, and in the end I have a tank. So just click on separators and tanks and select it. Okay. So these three So these 5 will be required. So let me show you what I mean by pipe segment 1 and 2. So you can see here that the piping is divided into two parts. The first is the inlet pipe which goes into the pump. This is our first piping segment, and second is after the pump discharge. So this 2 meter plus this valve plus 4 meter. Again there is a 4 meter pipe. Then we will consider a elbow here, 90 degree elbow. Then 30 meter length, and it's a 2 meter again. So this is my second piping segment, and we will see how to add that. Okay, so let me configure the inlet first. So just double click on that. I'm typing here water inlet. Press enter. Steam tables, temperature and pressure. Okay, so pressure is at 1 bar, and mass flow for timing I am assuming 1000 kg per hour. Okay, so this is what I have configured my inlet. Now next is the pipe, the second pipe which is going into the pump. Click on this. So pipe 1 inlet stream is water inlet. Then outlet stream is what we have to configure. So just press this create and connect icon. So this will automatically create. And then there is an energy stream. So since this is connected to a pump, so it will be energized. The pipe will actually flow water. So just click on the energy stream. It will automatically create. It will connect it as well. Okay. Now let me see how to configure a pipe. In hydraulic profile, in general, uh, just click on the hydraulic profile on the calculation parameters tab. So this is a one segment. Type is it's a straight pipe. Then quantity is 1. Material, since we have considered carbon steel, I am clicking on the carbon steel. Then length, so length of the pipe is 0.5 meter I have considered. So zero point 0.5, enter. And see elevation, since the pipe is rising to a certain level, so write elevation as 0.5. And external diameter, double click. As we said, it is a 2-inch schedule 40 standard. So just click on this and click OK. So my this pipe is configured now. Now let me just configure the pump. Similarly, click on the pump, then come to inlet stream. So inlet stream is MSTR02, which is the outlet of pipe 1. Create outlet stream by clicking on this icon, and again click on the energy stream, because pump is a energized entity. Okay. So calculation type, calculation parameter. So I am interested in outlet pressure. So I will put outlet pressure. Then so outlet pressure for time being, I am saying it's a 3 bar. I don't know what exactly the answer will be. Efficiency is 75%, and property package is steam table. So my pump is configured. Now the next part is very important. That is pipe segment 02, because this comprises of many parts. Let me recap. So now pipe segment 2 is this. Let me show you. So basically this whole segment is the segment 2. So there are 4 to 5 parts in that. First is 2-meter pipe, then the valve, then again a 4-meter length, then we have a elbow, then 30-meter height pipe, and 2 meter. So we will have to configure that in the segment 2. I will show you how to do that. Click on the pipe 02, give the inlet, that is MSTR03, then give The outlet stream, this is the outlet MSTR04, and also give a energy stream. This is a energy stream given. Now let us configure the different parts which are there in this. Now go to the hydraulic profile, and in that hydraulic profile, the first segment is our pipe segment, which is a straight tube. So this is already selected, a straight tube. uh, Quantity 1. Then the material, we said that it will be a carbon steel, so I am putting a carbon steel. Length is 2 meter, then elevation is 0, and our external diameter is 2-inch schedule 40 pipe. Just press enter, then click right button, so it will get selected. Now after this, click on this add section or segment button. Our second segment is a valve, so I will select a valve from here, gate valve. It's a PVC, so I'm selecting PVC. Then length, let me select a 2 meter, but it will change. By default it is 0.1. Elevation is 0, and external diameter is 2-inch 40. Press enter, and then select apply changes. Repeat it again, add a segment. Now our next segment is a straight pipe, which is 4 meter in length. I'm selecting the material again, that is a carbon steel, and length is what we said was 4 meter. Elevation is 0 meter. Then external diameter is again 2-inch standard 40. Press enter, select apply changes, again press add. Fourth segment, as we said, let me show you, is our bend, so it will come somewhere here. So I will put a bend there. It's a elbow 90-degree bend, so elbow 90-degree. Select the material again, that is a carbon steel. Then select length 2 meter, 0 elevation, and external diameter is again 2-inch schedule 40. Press enter, select this apply changes button, again press add segment button. It's our straight pipe of carbon steel again, but it is a 30-meter length pipe, so 30 meter. Press elevation 0, then external diameter is 2-inch schedule 40. Press enter, then select apply changes. Now we have a last segment, which is a small 2-meter pipe. We said straight tube, material is carbon steel, then length is 2 meter, elevation is 0, external diameter is 2-inch schedule 40. Press enter and select OK. Now you can also view how this segment looks like. You can see here there is a view tab, so if you select on this, it will show you how your view is looking like. Okay, now our all segments are entered here. Now let me enter the tank specification. The inlet of the tank is nothing but the outlet of pipe 02, that is MSTR04, and there is outlet we have to make, so outlet. And tank volume, we said that it will be a 60 meter cube. Press enter. Now it's time to run the simulation, so press F5, or on top tab you can see solve flow sheet button. So as soon as I click on that, it will solve and everything is blue. So let me check what are the pressures which we are getting. So for pump outlet pressure, as we said, we are calculating, so 3 bar is the outlet pressure. Then pump pressure, so here my pressure is way above 1 bar. Okay, now it is showing a proper. There was a small mistake. The elevation of a 30-meter pipe should be again 30 meters, so that we have missed. So let us again click on the flow sheet. So you can see it has solved the flow sheet again. Let me see the pump requirements. So outlet pressure is 3, and the pressure on this side of the pipe is just 0.06 bar. You can see when you just put a cursor on it, you will see that. But the problem here is I want this pressure to be equal to 1 bar, because my tank should be at that pressure. It's open to atmosphere system, the tank which I am looking to fill. So let me just add 0.94 to the pump outlet pressure, which will solve the problem. So I am adding 3.94, and again we solve the flow sheet, and now you can see it's the pressure here is 1.00631 bar, so that works. Let me see what is the time taken by the tank to fill. So it's saying the time it is taking is 59 hours, which is something which is not feasible. We want our tank to get filled in 2 hours. So press on water inlet. So just change it to 30,000, because since it is a 60 meter cube, so I would like 30,000 kgs to be filled, to be inlet in an hour, which should solve our problem. Okay, the moment I press 30,000, this much pressure is not enough. That's what it is saying. You can see a negative pressure was calculated inside the pipe segment. This means we need to increase the pump pressure. Now let me just put it 5. Okay, so 5 pressure is working at this. If you want to fill this tank in say 2 hours, 1.9. Again go and check this pipe. So it is showing 0.919 bar. Just add zero point 0.1 to this, so that our problem solves. Yeah, now I think it is solved completely. I have a tank at which is being filled at bar 1.01, and the pump outlet pressure here you can see it's 5.1, and water inlet is at 30,000 kg per hour, open to atmosphere. And let me see the power of the pump that needs to be required. So power required is 4.624. That is what it is showing. Now also you can check on the results bar. You can create a report here. There are different things which you can actually calculate. You can see there are a lot of things given. So pump available NPSH is also given here. So 9.3854. So I hope you like this real life problem where we have seen how to simulate an actual pumping system in a society. We learned here what should be the pump power, what should be the outlet pressure, and how to adjust the different pressure drops at different segments of the pipe. So thank you very much, and if you liked this video, please kindly subscribe to my channel and comment and like, and also share to those who you think it will be beneficial to. Thank you very much.